Recording this computer. Okay, it's recording right now. And now let me share my screen again. Okay, here we go. So number one, several of you actually missed this question. The answer is just going to be. So the problem that resists change in motion. So it's basically like, you know, the more mass you have, the more inertia you have. Like if I have more mass, it's harder to move me, right? Or you can't really move a car on your own because it has so much inertia. So inertia really deals more with mass than anything else. So not necessarily weight or gravity, definitely not friction. So that one was inertia. So I was checking to make sure you guys remember the first law of motion for Newton's laws, and that's what it was. Next up, I think most of you are fine here. Remember the SI units, or for force, we're using kilograms, not grams. So it's kilograms times meters per second squared. So just remember that's what we're using for force. And because you have 1,000 grams, you have to convert that to kilograms first. So that becomes 1 kilogram, just so you know. So that's 1 kilogram. That's what that is. Times 10 meters per second squared. So it's 10 newtons. And of course, don't put the newtons, so just put 10. And stop me if you have questions, by the way. And feel free to watch this video again when you're doing your test corrections, if that helps. Okay, clear the screen. And actually minimize that. There we go. Okay, for this one's a little tricky. If this two objects is doubled, now remember R, if you check your notes, we did talk about this. This right here is a equation we use for gravitational force between two objects. R is the distance between two objects. So if you were to double that, so R do 2R, now you're dividing by 4R squared. So it decreases by a factor of 4. That's why we're going to say that choice right there. And just, you know, the choices do get shuffled. The questions don't, but the choices do get shuffled. So if your first, if the correct answer was the first choice, it might have been someone different for someone else or for me. So moving right along. So you have two objects of those two different masses, and let their forces be F1 and F2. And so, yeah, so let the strength of gravitational force exerted by the planet on the moon to be F1, and the strength of gravitational force exerted by the moon on the planet to be F2. So that's basically the opposite force, right? So those are opposites. Well, here's the thing. The third law of motion states that in absence of any other forces, they're going to be the same. So who cares that one mass is more than the other? Like, for example, the force exerted on the Earth's center towards my body is the same as my body towards Earth's center. So even though the Earth's much heavier than me, that's why it's going to be that one. So that's the third law of motion. So that's conceptual. This one I thought was fine. Remember, you have 60 newtons to the left, 50 to the right. So you're just doing negative 60 newtons plus 30 newtons plus 20 newtons. Overall, it's negative 10 newtons. That's why it's 10 to the left. 10 to the left for sure. When you slide blocks across the floor, what must the force be stronger than? Well, you do have your normal force, obviously. You do have your weight due to gravity. You do have friction, whether it's kinetic or static. We'll call it static right now because it's not moving just yet. And so when you have to be stronger than in order to get it to move, has to be the friction force. Now, the friction force is a function of normal force, and normal force is a function of weight. But because you have that coefficient there, we don't know what that is. That's why we just say the friction force. So you got to be bigger than that, for sure, to get it to move. So that was also conceptual. This one is also conceptual too. There's nothing to calculate actually. The answer is just 500. Why? Third law of motion. Again, horse is 605 newtons on a heavy wagon. So the wagon on the horse, equal and opposite reactions. That's why it's 500. So that was another third law of motion question there. I think there's still one more. But remember, it's only worth 2 points. I'm not really asking you to do too much there. We'll keep moving. That is force due to gravity. Force is always pointing downwards. Normal force is always pointing away from the surface. So it tends to be up.
Mr. Amashni,
go ahead.
On my test, I put force due to gravity, but there's an X, and it says normal force is the correct answer.
Yeah, same for me, actually.
I think I fixed that for everybody, though.
Really?
Yeah, I think it may have. Let me double check. Actually, let me pause the video right now and let me just double check, because actually there was one actually where there was a mistake and I did correct that. That actually was much later. Let me check this one again. Yeah, because it should be forced to, but if that's true for everybody, then I need to go back and make another adjustment. Let me do this. Let me stop sharing. Let me end recording. Okay, we're recording again. Share screen. Yeah, so I'll make an adjustment. Everyone's grade, so that's a good thing. Everyone's grade should go up, because I'm pretty sure everyone probably said force due to gravity. But yeah, that's always pulling downwards. Force due to gravity. Air resistance is always going to be going like up, like against your motion. Friction force is obviously parallel to the surface. Normal force, again, that's pointing perpendicular to the surface. But force due to gravity is always pointing down, even if you're on a ramp or incline. Okay, now this one here. A 20 Newton block is being pushed across a horizontal tail by an 18 Newton force. If the coefficient of friction between the block and tail is 0.4, find the acceleration of the block. Okay, so let's draw a picture again. So now this is a 4-point question. You have to start actually doing a little bit of work. And I was checking to make sure your work you submitted helped support your answer if somehow you missed it. So we know this. And then we have our applied force. So our net force is going to be the applied force minus the force due to kinetic friction. Our net force, of course, is the same thing, saying MA. Our applied force is 20. And FK is going to be mu K times Fn. Well, my normal force is 18. My coefficient is 0.4. And my M is, I don't know my M yet, actually. So we'll come back to that in a second. So it's 20 minus 7.2, I think. So you should get 12.8. Okay. Now, what's the mass going to be? Well, here's the deal. We also know Fn minus W equals 0, or Fn equals W, which is the mass due to gravity. If that's 18, and gravity, of course, is 9.8, we can solve for our mass, which is 18 over 9.8. I think I got a cell phone right here. Hold on. Okay. Calculator. 18 divided by 9.8. No, 9.8. Okay, so you get 1.84 kilograms, which actually I'm going to incorporate over here. I'll kind of just keep copying that down. Then I'm going to do 12.8 divided by 1.84. And actually, I didn't get that. Wonder why. Yeah, 12.8. You know, I think probably,
Mr. Almashni,
go ahead.
Isn't the normal force 20 newtons?
Oh, goodness. I am just off today. Yes, so, crap. Let's redo this. The applied force is 18. You know what? I am going to clear all this and do it one more time. Okay, so, great. Normal force. Thank you again. I was not wrong about this, though. Goodness, come on, man. Okay, FNet, MA. FAP is 18, right? Minus mu K times Fn. Okay, mass I'm going to figure out 18 minus 0.4 times 20, that's pretty easy. That's 18 minus 8. So of course we get 10 here. Now, Fn minus I wasn't wrong about that, equals 0. Fn equals W. Now our normal force is, we're going to solve for that actually. So this is the way of the block. So that's why Fn is 20. So that's why I was able to do that over here. But because my weight is 20, I could say mass times gravity equals 20. Gravity being 9.8. So my mass is going to be 20 divided by 9.8. Which is 2.04. Okay. So actually I was a little premature in saying the normal force was 20 because that's actually weight and actually applied force. I probably should just do that, to be honest with you. I don't know why I'm just rushing this. So 2.04 A, 2.04 A, 2.04 A. So if you actually do 10 divided by 2.04, it's going to be close enough to 5. I think they did 10 for gravity, which is why 5 was the answer, but 5 is close enough. So you got that one there. Okay, sorry about that. Okay, I'm going to be a little more careful this time. Okay. So now this one here. A mass of 100 kilograms that rests on horizontal floor. So let's talk about this again. So horizontal floor, 100 kilograms. The coefficient static friction between the crate and the floor is 0.4. Again, here are all of our forces. And the coefficient of kinetic friction is 0.3. A force F of magnitude 340 is applied. Okay, 340 is applied to the crate parallel to the floor, which the following is true. Now remember, our F net is going to be FAP minus FK. Now, if you want to accelerate in the positive direction or have it move, right? Remember, FF's 344, and that's mu K times my normal force. Now, my normal force is going to equal the weight, and that's going to be 100 times 9.8, or 980 newtons. So if I want my net force to be positive, so first off, I have to break the static friction to get it to move. So I probably should just do that for now. So 3, and of course, you know, you want it to be a positive number, the net force. So if you do 0.4 times 980, once it's moving, then you use 0.3, of course, because it's kinetic. But if I do 0.4 times 980, I get 392. So that's not enough. That's actually going to be negative 48. So if anything, my net force is negative. So I'm not going to be able to move this object. So I can't be able to break it. That's also kind of why we have this little formula here, FAP minus mu S times Fn. You definitely need that to be positive. So you want this to be greater than or equal to 0, or y FAP must be greater than or equal to mu S times Fn. So we had that actually in our notes. So it's not going to move. That's that one. Your applied force is not bigger than the static friction force. So it's just not going to move it. And there's no other forces acting parallel to the surface. So that's that one there. So somewhat conceptual as well. Okay, here, so I use the word can. I try to be as careful as possible here. Which one can be true? And so in this case, if it has net force is 0, or F net's MA, so of course it means your A is 0. So it's definitely not accelerating, so that's for sure. It's definitely at rest, or it may not. Sorry, if it's 0 acceleration, that means you have a constant velocity. So your speed could be constant, or it could just be at rest. It could be either one of those two situations. That's why it's going to be those, because if your object's at rest, obviously that's a constant velocity. It's a 0 velocity. If you're not moving, you don't have acceleration. But likewise, you could have a constant speed, and that's possible. You can have a constant speed with a 0. Now, of course, you can have a constant speed with changing direction, and that could be accelerating. But I just said constant speed. Can that be true? That can be true. 13. What force are acting on a drop block as it's falling to the floor? Definitely gravity. But remember, it's falling through air, so it's not going to be friction at all. There's no surface whatsoever. But you could have air resistance also. Usually we say in the absence of air resistance, but in real life, you're always going to have air resistance. Sometimes it's not as big as it can be if there's like wind blowing upwards, but there is resistance to the air. We just ignore it to make the problem simpler, but it is there. So if you got one of those two, at least I'll give you a point for that. This one was also a little tricky. So here's how you can approach this one. So you're told that Pluto has 1/500th the mass of Earth and 1/15th the radius of Earth. Now you can look up the mass of Pluto and the radius of Pluto on Google. You totally can do that. But what you're going to do, if you make this easy for yourself, is realize that for gravity for Earth is 9.8, right? But now what we're going to do is replace the mass of Earth with the mass of Pluto. So Pluto's mass, so MP, is 1/500th ME. So we're going to, instead of doing mass of Earth, I'm going to do 1/500th of ME. Because what I'm really trying to do is I'm trying to get the gravity for Pluto, right? The gravity for Pluto is going to be the gravitational constant times the mass of Pluto, or the radius of Pluto squared. So that's what I'm kind of going through right now. And of course, the radius of Pluto is going to be 1/15th of the Earth. So what this means is that the 9.8 is going to have to be multiplied by 1/500th because of this right here. But down below, radius of Earth squared, if I square 1/15, it's 1/225, and that flips because it's on the bottom. So we multiply by 225 as well. So that's how you actually are going to calculate this. So it's going to be 9.8, come on, 9.8 times 225 divided by 500. You get 4.41. If somebody just put 4.5, I gave you full credit if you did, as long as you showed some work. But it should be, or I said round to one decimal place of 4.4. would be the answer for that one there. So remember, whatever changes you do on one side, you got to do to the other side to keep it balanced, right? So that's all we're doing. A little of algebra there. 15. Now remember, we want the force exerted on the ball during this launch. And we're assuming it's not an angle, so don't worry about that. Because I didn't say anything about that being an angle. But, you know, just force equals ma, right? Your mass is 2. And remember, acceleration is going to be your change of velocity over time. Your change of velocity is 10 minus 0 over 2. So you get 5. And so you get 10 newtons. That's what the answer is going to be, the last choice there. That's pretty straightforward. Okay, a lot of people missed this one. Actually, no. A lot of people got this one right. My answer was initially wrong. It's going to be the normal force. The normal force is always pointing up. I did go in and make a correction. If you still have this as incorrect on your end, let me know. I'll go back and double check. I think I accidentally had friction force selected as the correct answer, but it's supposed to be normal force. That's obvious, right? We have students sitting in a chair, so just pointing up. So it's going opposite to the gravity. So hopefully we're okay there. This one actually went pretty well for most people. You're asked to find the coefficient of kinetic friction of the skier if the kinetic friction force is 45 newtons. So what we're going to do is, you know, our net force is equal to W parallel minus the force due to friction, or kinetic friction, right? Our net force, hold on a sec here. 20 degrees. Okay, so we don't even need to do all that jazz. That's actually not even really necessary. Yeah, that was actually kind of pointless. Kinetic friction is this, right? Mu K times Fn, we know this, right? Our Fn is basically just going to balance out with the perpendicular weight. And that's going to equal 0. So our Fn is going to be our perpendicular weight, which is going to be, if we look at it, you want to do the cosine 25 degrees, so W perpendicular over W equals a cosine 25 degrees. So your W is, sorry, W perpendicular is W times cosine 25 degrees. So we just throw that in. And mu K, we're trying to solve for. Our kinetic friction is 45. And our normal force is going to be our weight, which of course is 62 times 9.8. We know this. Times cosine 25 degrees. And then you want to work all that out. So that's what you need to do. So I did look at your work if you got it wrong. If you actually did sine 25 degrees, and I gave you like 3 out of 4 points. So 62 times 9.8 is 607.6. Cosine 25 is 0.906. Work all that out. Let's see, 607.6 times 0.906. 550. Sorry, 0.4856 times mu K. Yeah, I guess something about close to 0.8. 0.082, I believe. So that's why 0.08 is going to be the correct answer for that one. So that's what you really need to do, is just realize that the normal force is the same as the perpendicular weight, right? We know this. If you have no other forces acting perpendicular to the surface. And then, of course, Fk is mu K times Fn. Once you know what Fn is, throw it in, solve for mu K. Oh, keep going here. This one, the car slams the brakes, comes to a stop. We actually did a problem just like this for our test as a review. So hopefully you guys were paying attention. I just changed the numbers around. So you want the distance to stop the car. So I probably should be using this formula. And I know I'm coming to a stop, so 0 squared, 25 squared. My acceleration, I'm trying to figure out. So I still need to know that. And of course, I'm solving for this. So how am I going to get my acceleration? Well, obviously force equals ma. And, or net force. And the coefficient of static friction. Actually, hold on a sec here. Well, if it's coming to a stop, yeah, so actually my net force in some ways is going to equal my negative FK actually. Because you are going to have, your acceleration is negative. So that's going to be m times a equals negative mu k times your normal force. So it's negative 0.7. Your normal force is going to be mg. So 800, because that's the only thing kind of acting on it perpendicular to the surface. You have a car. Here's Fn, here's W. So Fn equals W. And m again is 800. That actually doesn't matter. So your deceleration is actually going to be 0.7 times 9.8. So you get 6.86, or negative 6.86. You're going to throw it into here and solve for the distance. If you do that correctly, 25 times 25, 625, divided by 2, divided by 9.8, sorry, divided by 6.86. Let's try it one more time, 25 times 25, divided by 2, divided by 6.86. Yeah, so you should get about 45.5. That one. 19. They're doing tension. So you have a ceiling, and you have a guy climbing a rope, going upwards. So the tension will be that way, and the weight to the person is that way. Our net force is our tension minus W. So our net force is his mass, 60 times 1.5. The tension of the rope is what we're trying to find, and the weight is going to be 60 times 9.8. And that's all you're working out. And if I do that correctly, yeah, you should get 90 here. And 588, so you should get 6, yeah, 688 newtons for that one. So that's that one there. And that would make sense because because you're kind of pulling on the rope, right? If you think about it. So if you didn't do, if you just kind of just stood there or just kind of like stayed on the rope and didn't move at all, then of course your tension is going to equal the weight due to gravity. But because you're tugging on it, or you're pulling on it, and you're pulling yourself up, that's going to add more tension to the rope, right? So that also kind of makes sense. It should be higher than 588. And lastly, this one. This one was just straight from the notes. I just changed numbers around. So remember, that's F app in the X direction, F app in the Y direction. We know that Fn plus F app Y minus W equals 0. Our F app Y is going to be our F app, which I know is going to be 200 newtons, times the cosine of, no, the sine of 40 degrees minus the weight of the wagon, which is 50 times 9.8. So you got to use your calculator and work all that out. We try to do this correctly. So see sine of 40 degrees, which is 0.642 times 200, which is 128.557. And then minus parentheses 50 times 9.8 and the parentheses. So your normal force should be 361.44. Many of you guys got it. Some of you guys were a little off. If you were just a little off, but your work was fine, I give you full credit. If you guys saw there's a little mistake in your work, then I gave some partial credit there. And then the coefficient of kinetic friction. Then remember, our F net is going to equal our applied force minus our force due to kinetic friction. As our applied force in X direction, mind you. And that's going to be, hold on a sec here, constant velocity. So that's zero net force. And that's going to be F app, which is 200, times the cosine of 40 degrees, minus mu k, times my normal force is 361.44. You try doing that correctly, you should get 200 times, I'll go side to the calculator again, cos 40 minus, they'll leave it like that. So you get 153.2, and then you got to divide by 361.4, and you should get about 0.42 from UK. And I said, yeah, make sure to place 0 for the decimal point. So, okay, so that's the test right there. And I did make a little mistake early on, and I will go back and change number 9 for the force one. So I'll go make sure I'll do that. Okay, so any questions about that? Nope. Okay, cool. So if it helped, I mean, if you got them all right and you were kind of just sort of just sitting idle, that's fine. But I want to make sure at least I did that. So I'm going to stop this recording just so this is dedicated towards the test solutions, and then I'm going to start a new one for our current